Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Ahmad Wa'id bin Wa'idni. So we will present this lab which is series and parallel pump. So this is my group member. This is Nur Atika binti Ahmad MA18101. Second is Muhammad Anif bin Saiful Nizam MA18108. Me, myself, Ahmad Wa'id bin Muhammad Azmi, MA18121. Next is Muhammad Aris Izham bin Rostas Nizam, MA18149. And Kumar Resak anak lelaki Mohan Ravi, MA18163. So next, I will explain about the abstract. So the abstract, basically the pump configuration in the piping installation is varied to achieve the performance of flow characteristics required in a specific application, such as the requirement for a head greater than the flow rate, which is capacity, or vice versa. The pump efficiency range of the parallel circuit pump is high to acquire a bigger flow rate than the series circuit pump. So according to the flow control method, the variation of path is openly. So for the introduction, fluids are moved using pump. They are available in a variety of sizes and styles. The goal of this practical is to familiarize yourself with how pump system react when coupled in series and parallel, as well as the flow of fluids through parallel and series pipe system. We also like to get a better understanding of the pump curve. So for the project background, a pump is mechanical device that converts mechanical energy from the outside into hydraulic energy, letting liquid to flow from one potential to another. The pump are connected as a single plug in this experiment, with two pumps, which is series and pump in parallel. There are two centrifugal pumps are connected by pipe from the system. So the problem statement is pump engineers are continually challenged to create systems that are more efficient, silent and trustworthy while maintaining a low cost. Several academics have utilized CFD as a numerical simulation method to undertake various investigations on centrifugal pumps. This entails, among other things, research into enhance the efficiency of the pump that will be utilized in the industry. So this section teaches the student through pump study in order to evaluate the pump performance, which includes both series and parallel pump. So for the objective, this laboratory goal is to demonstrate the pump performance curve for single pump configuration, series pump and parallel pump. Second is to measure the hydraulic power output of the pump. And the lastly is to compare the pump performance curve using different pump. So for the scope of experiment, the experiment is carried out using a single pump with two pump in series and two pump in parallel. So the bench regulating valve will be closed completely. The system is made up of two identical centrifugal pumps linked by pipe. And the lastly is time water collection can be used to determine operational characteristics. So that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Saiful Nizam and my matric ID is MA18108. So for this experiment, which is series or parallel pump, my part is about a theory. So we continue for the series pump first. Pumping in series refers to one pump acting as a booster for another pump. So let's say if pump 1 fail, then pump 2 will have problem to operate and the flow rate will drop near to zero. This problem happen because when pump 1 fail, the suction flow to the pump 2 will already cut off and may cause another problem if pump 1 not stop immediately. Next, we go to advantage of the series pump is upgrading the current system is less costly. So for this advantage, we can upgrade the system from time to time in order to make sure the pump system will operate efficiently and supply the demand. Last one is disadvantage that we need to consider for the series pump is the series pump requires more equipment to operate and more moving components. Also, this series pump demand more floor area to install. This figure shows the series pump curve. For the experiment, if we use two similar pumps and will operate at the same flow rate but deliver a different level of heat. Next, we continue for the parallel pump. Parallel pump most common piping system that implemented nowadays, especially in the water treatment business. This parallel pump will design to flow rate is split amongst two or more pumps in parallel pumping. Let's say if we have two pumps, the load will split into 50% for pump 1 and 50% from pump 2. And if we have more than two pumps, the load will split equally for each pump. So next, the advantage of parallel pump is to have a limitation of pumping fluid from low level to high level. This figure shows parallel pump curve. For the parallel pump system, each pump will operate at the same heat but share the flow rate with other pumps.
Hi and Assalamualaikum. My name is Nur Atika binti Ahmad, MA 18101. For the experimental setup, the system consists of two identical centrifugal pumps linked by pipes. Manual valves allow for rapid switching between series and parallel operation. Manometer measure pressure at all critical places in the pipe systems. Pump characteristic can be saved. The pump's hydraulic power output can be measured. The equipment provides water supply and volumetric flow rate measurement. To prevent any equipment misuse or damage, perform the following checks before performing any experiment. Fill the sump tank with the water from the tap. The viewing glass may be used to check the water level. Make sure the emergency off switch is turned off. Turn on the main power switch. Volume flow adjustment valve is open. Turn on the water pump. For the experimental procedure, first is experiment 1. We do the single pump operation. As shown in figure above, the stopcock were connected. Handle parallel to the pipe means valve is closed, and when the handle perpendicular to the pipe means valve is open. Pump 1 was turned on with the main switch on the switch box, while pump 2 remained off. Volumetric V was set with the drain cork, and we ensure continuous water inflow into the reservoir. Then, in the experiment 1, we measure value of P suction, P delivery, and volumetric flow. Then with very volumetric flow, we measure the measuring procedure repeated 6 times more. For the experiment 2, it is the same procedure, but with both pump 1 and pump 2 were turned on. And we measure the P suction 1, P delivery 1, P suction 2, P delivery 2, and volumetric flow. Then we repeat also 6 times. On the figure, we can see the flow for the series pump operation. For the experiment 3, which is parallel pump operation, We can see from the figure its flow different from the other experiment. For this experiment, we also switch on both pump 1 and pump 2, and then we measure value of P suction 1, P delivery 1, P suction 2, P delivery 2, P outflow and volumetric flow. Then we repeat the procedure 6 times. So that's all from me. Thank you for
Hello, my name is Kumar Resan. Matrix number is MA18163, and now I'm going to present about the results and discussion. So first we will look into the experimental data sheet. So this is the table for the first data, which is for the single pump configuration. This is the second data table for the second experiment, which is series pump configuration. And thirdly, we have parallel pump configurations table. So now when we execute the data tables into graph, so first we will have a look into the net head versus volume flow rate for the single pump configuration. So as we can analyze, so the performance curve for a single pump, and it shows that the pump head decreases as the flow rate increases. So we can conclude that the relationship is that the head pump does not correlate with the flow rate when using one pump or single pump. Secondly, we will see the data plot for the second data, which is for the parallel pump configuration. So as we can see that there is a steady decrease of the net head when the volume flow rate increases. And thirdly, we will see the graph for the series pump configuration. So as for the series pump configuration, the performance curve shows that the flow rate increases, so the pump head decreases steadily. So the series pump configuration do not have a linear relationship between the head pump height and flow rate. So this is the data calculation. So first we will look into the net head value calculation for single pump configuration. So the formula is head is equals to pressure over rho times gravity. So as I provide an example below, so the first value that I use, which is the 254.71, that is the pressure of delivery, and I get the value of head. So this is the calculation for series pump configuration. So the formula is head is equals to pressure 1 plus pressure 2 over rho times gravity. So when we see into the example that I have provided, so the 250.18 is the pressure delivery 1 plus 294.89, which is the pressure delivery 2, divided by 1000 times 9.81, which we will get 0.055562691 meter, which is the net head. Secondly, we will see into the calculation for parallel pump configuration. So the formula is equals to pressure over rho times gravity. So the first value, which is 119.83, that is the value that I got from pressure delivery 2, and when we calculate the values, and we will get the net head. Now we will look into the water horsepower calculation for single, series and parallel pump. So the formula for the horsepower is rho g QH. So for the example that I provided, so we can see that 1000 times 9.81 times 0.0004155. So that's the value. So these values I get from the single pump configuration. So the first value is 0.0004155 I got from the volume flow rate, which I times with the net head, and the resultant is I got water horsepower in watt. So now we will look into the discussions. So the first question is compare the experiment performance curve to its theoretical curve and describe the discrepancy factor. So by contrasting the real and hypothetical performance curve, so we might infer that the parallel pump has the highest flow rate and the series siphon has the most head value. So while contrasting the experimental and hypothetical curve, the experimental curve shows a tremendous distinction. So information for the trial result is untrustworthy due to pipe loss and flow rate variances during the activity. As for the second question, from the results obtained, state the use of series and parallel pump. So for series pump, we use it for conquer a high static release head or very long length with frictional losses, and series pump is acquired by adding the head at a similar flow rate. As for parallel pump, it is utilized about a performance curve, performance pump to same in series pump. And the third question is explain why the system with series pump configuration will generate higher pressure than the parallel pump configuration. So the pump in series are utilized to make up for a bigger framework head loss than a single pump can deal with. Then again, a parallel pump configuration can give a much more flow rate than the pump setup, given 2 times as much head as equal pump design, bringing about higher pressure. So at that point, the net head increases too. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Riza Hamdur Hasan Nizam. My ID number MA18149. For this week, we perform the experiment series or parallel pump. My part will discuss about the discussion first. Throughout this experiment, we can get we noticed that to get more accurate value using strain and flow sensor, virtual instrumentation modeling is used. We can use the instrumentation modeling to get a more accurate value using strain and flow sensor. Second, we learn how to investigate the relationship between pressure head, flow rate, power consumed, and pump efficiency. Third, the arrangements of pump configurations has a significant impact on pump head and flow rate delivery. And lastly, at the same flow rate, the pump may provide twice the head of a single pump when used in series. Meanwhile, a parallel pump will produce twice the flow rate by putting less pressure on the pump. So that we can conclude that we can use a parallel pump. The parallel pump is more good to use rather than use a single pump. That's all for me. Thank you.